Hey, what's up? In this video I'm going to be explaining the difference between ionic bonds, polar covalent bonds, and non-polar covalent bonds. The first step is to compare the electronegativities of the elements involved in these bonds. So if the elements have equal electronegativities, that means that it's going to be a non-polar covalent bond. If the electronegativities differ between 0 and 1.7 of each other, then it's going to be a polar covalent bond. And if the electronegativities differ by more than 1.7, then we have an ionic bond. Next, we want to describe how the valence electrons are going to behave in these different bonds. For a non-polar covalent bond, these electrons are going to be shared equally because their electronegativities, or their tendency to attract electrons towards each other of each element, is going to be equal. So it's fine for the electrons to be equally shared. However, in a polar covalent bond, it's going to be unequal sharing because one of the substances is pulling harder than the other because of the electronegativity difference. Finally, in ionic bonds, they're going to have electrons full-on transferred, not even shared, because of this big electronegativity difference, so one of them pulls them a lot harder than the other element. Now some examples of these different bonds in action. We got H2, which has non-polar covalent bonds. Often diatomic particles like H2 will have non-polar covalent bonds because they just contain two of the same element. CO2 has polar covalent bonds because carbon's electronegativity is 2.5, oxygen's is 3.5, therefore the difference is 1, falls in that 0 to 1.7 range. And NaCl is going to have ionic bonds because the difference is greater than 1.7. We've got a difference of 2.1 right here.